Morning students, today we are going to see about 8051 timer programming in assembly. Okay, so here in basic register of timer is timer 0 and timer 1. They both are 16-bit wide, and each 16-bit timer is accessed as a two separate register. One is your lower byte and second one is your higher byte. Next, the timer 0 register is something that the lower byte register is called as timer 0 low byte, that is TL0, and the high byte register is referred as TH0. So it can be accessed like any other register, such as like accumulator, B register, R0, R1 and R2. So here the instruction, the move TL0 comma hash 4FH, here it moves the value of 4FH into TL0, and so this is a format of timer 0 register here, where D0 to D7 is for lower byte, and D8 to D15 is for higher byte timer 0 register. And similarly based on timer 0, the timer 1 register also 16-bit, and it is split into 2 bytes, that is, one is your timer 1 lower byte and second one is your timer 1 higher byte. Okay, so this can be easily accessible similar to your timer 0, and this is your data format, where here D0 to D7 is for your low byte, and where D8 to D15 is for your high byte. And we have a T-mod register, where timer 0 and timer 1 use this T-mod register to set operating modes, and it is an 8-bit register. Lower 4-bit are for timer 0 and upper 4-bit for timer 1, and lower 2 bits are used to set the timer mode, and upper 2 bits are used to specify the operation. So this is a T-mod register. For example, here the gate which is representing the gate control when it is set, and C/T is something is timer and counter, that is selected cleared for timer operation, where M1 is your mode bit 1 and M0 is your mode bit 0. This is the T-mod register. Next is your clock source of timer. Here the timer needs a clock pulse to tick. If C/T is equal to 0, the crystal frequency attached to 8051 is the source of clock for the timer. And next one is a frequency for timer is always 1 by 12 the frequency of crystal attached to 8051, where the oscillator frequency is around 11 megahertz. And next is your mode 1 programming. Here it is a 16-bit timer. It values from 0000 to FFFH, where TH and TL are loaded with 16-bit initial value. Here timer started by set B TR0 and for timer 0, and set TB for timer 1. So timer count ups until it reaches its limit of FFFH. So this is your block of timer 0 with external input at the pin of 3 and 4, and this is a sample programming in which we are creating a square wave of 50% of duty cycle. Timer 0 is used to generate the time delay. So move T-mod comma 01, here timer 0 mode 1, here move T-mod TL1 comma 0F, something that the F2H will be moved to the timer 0 lower byte. Next is 0FF will be moved to your higher byte. So CPL is complementing P1 comma 5 is toggling the P1. Next is you are calling a delay and jump. Okay, then after a delay you are setting TR0 of timer 0, and then next is your jump instruction, then clear timer 0 and timer flag result. And this program we can execute the square wave of 50% of duty cycle. And next is an example of to generate a square wave on the pin P at 1.5 continuously using a timer 1 for time delay. Find the frequency of the square wave with crystal frequency around 11 megahertz. So here move T-mod comma hash 10, that is the timer 1 is set as mode 1 here. Here TL1, the value of 34H which will be moved to the lower byte of timer 1, and set B TRB. So here it starts the timer, then stay until the timer is roll over. Next is your stop timer instruction. Next is your complement E15 to get high or low. Next is your TF1, that is reload the timer since mode 1. And next is your end process. So this is an example for generating the square wave. And if you have any clarification related to this topic, feel free to contact me. Thank you.